We're going to be talking today about agent-based modeling for CryptoFinance or cryptocurrency ecosystems in Splunk. I'm Nick.
And I'm Zach.
So we're going to do the best job that we can to speak accurately about everything that we're doing, and don't use anything that we say against us or Splunk, please. Okay, so about our company. The company name is Inca Digital Securities, and we are a data provider generally for the digital asset ecosystem. The company was founded by this guy up here with the alpaca sweater and Evgeny. This is Adam. They met about, just the backstory, they met about 10 years ago while doing intelligence at Interpol, and they went their separate ways. Ev was doing security for the Bank of France. Adam he got a law degree and was a JAG in the Air Force. They found out about Bitcoin, started getting interested in it, started doing some trading, and while they were doing that, they wanted to build out a data platform themselves to make smart investment decisions. So they were doing things like integrating mining pool data with financial data into one place to try and do arbitrage with mining contracts. And so they started building out an intelligence platform for that. And then as 2017 was starting to ramp up, more big players were getting into the space. They decided they should focus on their core competencies and focused on building out the intelligence platform rather than trading. So now we have a platform called Nakamoto Terminal, and we provide data to a wide array of players in this space. We have financial regulators, traders, investors, exchanges, research organizations like Forbes, and we provide to the SEC. So within the company, I kind of sit in between the tech side of things and the business side. I help out on the research side and working on this project that I'll be talking about today. But I have a little bit of a not normal background in this space, coming from neither computer science or finance. I studied neuroscience, worked in studying neurodegenerative diseases, and helped start up a pharmacogenetics lab. And
just like Nick, I also come from a neuroscience background, a little bit more in the focus of computational science. In school, I studied computer science as well, so my background is a little bit more in the lines of software programming, and I've done some statistical analysis in some clinical research labs. My job at the company sits a little bit more in the tech side of things. I help to execute some of the business and research goals and work alongside Nick in a modeling project that we're going to be talking about today.
All right, so the general overview for the talk is we're just going to briefly touch on cryptocurrency ecosystems. Everybody might not be super familiar. Then we'll talk about our current platform, how we use Splunk, and then we'll talk about what we're doing research and development-wise on this agent-based modeling platform we're starting. All right, so a little bit about CryptoFinance. Obviously, it's a pretty new industry. It's not well understood. Right, there's a lot of moving parts, a lot of data streams that are kind of messy. It's hard to know what the truth is. So with this, very complex ecosystem, it's really hard to navigate the space, make smart decisions, and even understand what's going on. So to deal with this, as I alluded to before, we started building out this platform called Nakamoto Terminal. And Nakamoto Terminal is essentially a data aggregation and analytics system generally for cryptocurrencies.
So our company uses Splunk to handle this. Like Nick was saying, cryptocurrency and crypto finance is a pretty broad area of data, and we needed a solution that was flexible for integrating data sources from a wide variety of places. We also needed a set of robust tools to help parse through the noise, because there's a lot of noise in the data that we're integrating as it's a maturing ecosystem. And so while we brought all the data together, it still needs something to cast some understanding to it. We don't necessarily know and understand how all of these components of the ecosystem fit together, and it's not intuitive how we can abstract meaning from it. So we needed a system and a way to understand and model and start to abstract some of the complex interactions between some of the pieces of data that we're monitoring in our system. So Nick and I started off by researching some of the available analytics and tools out there for modeling data. We looked into machine learning and neural networks. Those we found out were very good at picking up on specific and fine-tuned patterns, good at image recognition. This is something that was a little too refined for us. We needed something that was more generalizable and adaptable to the changing ecosystem of crypto finance. We then looked on the other side of the spectrum, which was related to agent-based modeling, which is typically used by biologists, so similar to the field that we both come from. And this was a type of model that's very good at running out simulations, but it requires a well-known set of rules about the ecosystem. These are things that we don't have in relation to crypto finance, and we believe that the rules are quite dynamic in the ecosystem. So we wanted something more adaptive to the changes that we're monitoring in Splunk. So today we're going to dive into some of the more nitty-gritty aspects of NTerminal and then discuss the model that we came up with as a solution for this.
Yep. So talking about NTerminal, again, that's our data aggregation and analytics tool that is currently an available product. Just the flow of data, obviously it's produced by the real world, by entities within cryptocurrency ecosystems. Then we pull the data into our aggregation system, analyze it, and now we're working on trying to build architecture on top to try and derive more meaningful insights. So what type of data are we working with? Generally, we like to categorize it into 3 different categories. So the first would be technical data. That could be coming from blockchains themselves. So we run our own nodes on different blockchains. That could be third-party providers that are providing some derived metrics on the data, or code repositories where the developers are working. The second category generally is financial, so that can come directly from centralized exchanges, from smart contract platforms, or from some of our third-party providers. For example, Tacit, one of our partners, provides us pricing data on dark pools for trading over the counter. Thirdly, natural language. So this is a broad category encompassing all natural language data. That could be coming from traditional media like Washington Post articles, social media like Twitter, or like regulatory decisions or chat channels. So all of these different natural language sources are turned into structured data streams enriched with things like sentiment analysis, as Zach will talk about a little bit more, and all put in one place. So we're dealing with a lot of different endpoints, and this kind of drove what our architecture is.
So now we're going to go through the infrastructure and architecture of our system that we built to account for the wide diversity of data endpoints that Nick was talking about. So just to touch upon the technology that we use Spring Cloud Dataflow with Kubernetes and RabbitMQ. And this is an image of our content delivery chain, something that we like to call the CDC. And in the salmon color over here, we have a set of modules that is called the sources. The sources reach out to different data endpoints and pull in raw data events as they occur live in the ecosystem. This is the way that we keep our system continuously updating with changes. The data is then sent to a message broker, which is routed to our processors. These are another set of modules which work to filter and enrich the data. This is, like Nick was saying, where we apply sentiment analysis on natural language data. The processors help us to restructure the data into a format that is useful not only for us, but our clients. And everything is then stored in raw content storage, and then it's sent back to the message broker to be sent to an array of sinks. So we supply our clients with custom endpoints, giving them data in however structure they would like. And then we also send it to our Splunk sink, where that can be fed into our Splunk instance so that we ourselves can run analytics on the data. And then if you see, there are a couple modules which are black squares, and these are modules related to Upana that we've just highlighted out. So Upana is the modeling project that we talked about, and they're particular to identifying entities in the ecosystem, as well as applying some enrichment processes that are going to help us in parsing out some analytics for the module that we're trying to build. So let's go through a quick data lifecycle. One of our source modules will pick up an event. So for this case, we're talking about a tweet. which is then sent to our processor. It will then filter the information for different important pieces of data. So it'll take the text body, it will take any entities that it recognizes, any links, any text within the links, and images. The images will be scanned, and any text within the images will be pulled out. And then we apply keyword and entity extraction on those texts and sentiment analysis. It's then structured into an event depending on the type of sync that we're going to feed it to, which is dependent on whether or not we're using it for analytics or sending it directly to our clients to be used. And then it's sent off. And for us, it ends up in Splunk so that we can use it to parse out some analytics. And here's just an example of the 3 categories that Nick broke down, and they're indexed into different areas of Splunk, separated by sources, source type, and index. So we have technical, financial, natural language.
All right, so once the data's in Splunk, obviously you can do some cool stuff with it. So what we're looking at is building out alerts for ourselves and reports so that, let's say, an exchange API goes down, we can notify our clients what's going on. We can start helping them while they're troubleshooting any problems that they're going through when they're trying to trade or anything. So to go through an example of how we're using Splunk to monitor the ecosystem real time with NTerminal, I'm going to talk a little bit about indexing Bitcoin trades coming from multiple exchanges and classifying what kind of trading volumes the exchanges are publishing. So here we can see that we're filtering for just Bitcoin trades coming from US dollar and US dollar stablecoin based pairs. And we're filtering, it's probably hard to read, but we're filtering for a selection of like 5 or so exchanges. Then we're going to run some basic stats to categorize the trades that are coming in based on the size. And then we can build a dashboard that monitors for any given time period what the trade size distribution is. So what you see here on the top is a normal curve, what looks like, and this is, on the left side would be really, really small trades. So these are minuscule size of pennies. And on the right would be hundreds of thousands of dollars worth of trades in Bitcoin. And obviously the reason the normal curve arises is because small trades are unfeasible from network and trading fees, whereas large trades don't happen that often. Most people don't have a lot of money. And what we see when we're analyzing this is a lot of the less well-known exchanges publish really strange trade distributions, and sometimes at specific times when they're pumping their volume or someone else is pumping volume on their exchange, you see on certain coins the trade size distribution gets extremely skewed, sometimes with all of the trades being published within like the 1 Bitcoin size, for example. All right, so now that we have all this data running into this aggregation system, we can use Splunk to run real-time dashboards and get some intelligence out of it. We want to get a little bit more insight to the data. So what we're trying to build is a continuously updating agent-based modeling system that can deal with these asynchronous updates from heterogeneous sources.
So when we get into the remaining slides, we're going to be pulling on some terms that are related to machine learning techniques and agent-based modeling techniques, just to provide some clarity in terms of the definitions that we're using. So the first step in building this model was characterizing the units that we wanted to use to section off our data into pieces that we could actually work with. So the first step is creating agents. So an agent to us is representative of an entity within the real ecosystem. And the way that we have set up to, or how we're trying to implement this, is through different fields that we have in data events that will combine data across time and across different sources. So we have up here listed a couple different field types that we use currently and are testing out for characterizing and classifying agents. Could be the source that they come from, the individual user ID from a social media service or another account's user ID. We also do aliases and usernames that we find across different sources, as well as affiliations. So if we have a number of Twitter users who say that they're affiliated with a particular company, asset, or project. That's another way to characterize agents. And then tags and categories. So this is a more method that we're testing out currently of tagging agents dynamically and then combining them under different communities and tags.
And so anybody who's aware and familiar with the cryptocurrency space knows that there's a lot of bad actors and fake Twitter accounts. Vitalik has his post being the non-giver of ETH, I believe. So even just classifying agents is, it's a difficult task in and of itself. All right, so then we have to try and organize them into some kind of structure now that we have these entities that we're defining. And the structure that we're landing on needs to be something that can both scale horizontally as new agents are detected and integrated, but also something that can scale vertically to try and understand the relationships between these agents and the groups that they are a part of. So on the far left here, you can see that there are layers of what are agent networks, and these are just individuals. They can be thought of as agents that are receiving updates from individuals within the real world. And then there are groupings of them by some given axiom that would form a higher order agent group node. And these nodes can in turn form their own network and relate to each other in different ways. And then a concentric group of them by a given axiom can form a higher order node. To kind of clarify this, we'll use a simplified example within just social media. So you can see here that there are different groupings of agents, and these are all based on, their groupings are based on which platform they are receiving updates from. So the ones on the far left are agents that are receiving updates from Twitter accounts. For simplicity's sake, we don't have overlapping connections here, but any agent could be receiving updates from not just multiple Twitter accounts, but also from different data types in total. So one agent could be affiliated with a mining pool, or also might have a GitHub account. And updates to those data streams would also affect that agent and further create that agent or classify that agent into different groups. Then you can see for Twitter, there is one single group node that can be thought of to represent that entire grouping of Twitter. So any tag statuses there would kind of be representative of what Twitter's sentiment is or something. And then that can be related to what the other social media platforms are in that layer. Then above that is a master node, which would be representative of all social media. And the reason that we have this architecture, which can also scale further vertically, is so that we can try and understand when the milieu, in some kind of way, for let's say all of social media seems to be really negative about a project as an event is happening, we can see what the constituent agents are feeling and whether or not they are driving factors for that causal effect, and then see how social media compares to mainstream media, for instance.
So now that we've talked about how we characterize agents and how we have built the structure for them to be in, we're going to talk about the properties of a specific agent. And this will help define the actions and the interactions between agents. So the first property is a status. So an agent will have a status or a set of statuses that represents values within the data, which is abstracted into a state. So a state might be, in the example of a Twitter user, a sentiment level towards a particular keyword. So this person might be positive towards Bitcoin. So the state is something that we deem as a meaningful value that we want to abstract from the data points. And the status is going to be the actual data point that we abstract it from. Relationships, this is the way that we are connecting agents and building the network that Nick discussed in the past two slides. In the example of a Twitter user, which I'll keep going with, is that one Twitter account can follow another Twitter account. This is a pretty robust and concrete example of a relationship. These are kind of the starting points of how we're going to build the networks. And then the last one is a weight. So this is applying a direction for the relationship. So in the example of Twitter, I may follow Nick on Twitter, but we may have opposite opinions about Bitcoin. So this is going to influence our relationship and also influence how our two individual statuses will interact with each other. One way that we like to conceptualize this and think about it is in the context of neuroscience. So agents to us are like neurons, which hold a state of being active or inactive. The relationships between neurons are their connections, their synapses, and the weights are the kind of sense of learning that's been applied over a neuronal network. So this is kind of what we wanted to instill in the network and the properties of the individual agents. And so right now we're testing out how to measure these properties in Splunk. So we are using scheduled reports and searches to iterate through the historical data that we have and the data that's continuously updated in our system to generate status values and weight values between different agents. We're then leveraging some of the relationships which are more stable across searches and iterations to apply the weightings and the statuses to generate some understanding of whether or not the values we're generating are accurate. So we're testing what we are building with these summary searches against actual live data that we're monitoring from the space in the future.
Yeah, and the reason Splunk is so great here is because it allows us to very flexibly iterate and try out different ways of defining these status values, categorizing the relations, and then testing different models for creating weight scores. So if we were doing this in another infrastructure, it might not be as easy to just continuously iterate and see what the results are and compare them. All right, so we'll just talk on some of the use cases. The first one here.
So the first one we're going to talk about is community engagement. So when I was talking about characterizing agents, we discussed tags and categories, which is one way of classifying different agents and communities. And in this way, we're looking at the level of engagement of different communities, which might be useful for someone to, say, look at the level at which financial agents are engaging in the asset as compared to the developer community, which might give an indication of the relative health or interest of different communities across the ecosystem. So this is looking more particularly at our natural language data to see the level of sentiment and activity from different communities that we've tagged and comparing them across time to see as they fluctuate with different data points that we're also integrating.
Unfortunately, we develop really quickly, and these slides were made many months ago. So it'd be cool if we had some of the more recent examples up, but one of our interns is currently working on defining influence scores and trying to see different actors within our natural language data category and trying to determine who is actually influencing what types of groups of users to make different decisions or who is driving the sentiment at a given time based on a different event. Mm-hmm. So sometimes an event will break and you see, like during an exchange hack, some of the people will be extremely negative, as you might be if you had lost funds during that event. But some users are going to be defending the exchange, and then it's interesting to see the people who are following these users, and maybe not just on the same Twitter platform, but on other accounts, to see how those kinds of things spread over the network. Another use case is tracking the development of a project. So obviously, if you're going to be making an investment in a project and the project is promising these lofty goals at some point in the future, a lot of your investment returns are going to be based on the fact that that development is actually going to happen. So our investment clients definitely like to keep up to date with the development status. And just for investment, that's an obvious use case. But then regulators and exchanges definitely need to be wary of which projects are actually being developed, have serious developers on the team, and don't just have a bunch of shell accounts that they created that were on a recent fork of a project.
Yeah, another point there is we can also we are diving deeper into the actual accounts that are contributing to projects to give an indication, like Nick was saying, on who is behind the project and the level of centrality across users who are contributing, which might give an indication of whether or not the project is serious or if it's really just a sole group of young users who've jumped into blockchain and are trying to build out a project.
Yeah, and then correlating things like this with some of our natural language data or what's happening on the markets you can try and use to try and predict whether or not development's going to increase or decrease. If people are getting super negative and that's coming from the security and development communities, maybe developers are going to be getting driven over to other projects, which is kind of what we've seen over the past few months. We've seen a big consolidation of developers leaving these small projects that were raising a lot of money 2 years ago, and they're kind of moving in towards these bigger projects and starting to work together a little bit more. Another use case is trying to categorize market participants or actors within the ecosystem that are actually using blockchains. So by trying to understand what an actor within the ecosystem's activity would be, you can use some algorithms to determine or to classify them with some degree of certainty. Here, what we have is some blockchain data overlaid with some financial data. On the left, you see these are potential clients being noticed, and the way that we're doing this is these are multiple transactions, and when we see that there's probably a middleman sitting in the middle where there's a large amount of Bitcoin entering a wallet, instantly being relayed over with nothing else being left behind besides maybe the fee amount, and then it enters an address that we have tagged with exchange activity or a known exchange that was scraped from that wallet being on a public source that labels these things, then we can classify that as an OTC provider. And if you are an OTC provider, that might be interesting to see what your competitors are doing. And then also if you're just trying to make trades and you see some really large OTC providers all doing something similar, it might give you a sense that the market might be moving. And this can also be done not just with OTC providers, obviously, but more generally to try and categorize how much of the network is being utilized for actual retail versus how much of it is peer-to-peer transactions, how much of it is just speculation going on.
We also, as Nick was saying, scrape from the web different addresses which have been tagged to entities. So in this example, we're using Binance, which is a prominent exchange. And we are tracking their movements of funds across the set of addresses that they have and combining the blockchain data, the transactional data, with our financial data. So some of our clients are interested in seeing if there are large transactions and how they affect large movements in the price. So we can actually identify entities in the blockchain, track their movements and their activity, and then see how much push they have on the volatility of the metric as a whole.
All right, so kind of a recap of where we came from, and then I'll talk a little bit about where we're going. We started off by just generally doing research about the space, trying to understand what kind of solutions were needed. And we were looking at existing frameworks, as Zach had mentioned, looking to machine learning techniques and some of these maybe less traditional techniques like agent-based modeling, and trying to kind of pull on both of them. Then we started having a lot of conversations with a lot of really different types of people who think differently, like evolutionary biologists, and started, while we were building out our infrastructure, setting up the content delivery chain, also trying to get clients so that we could keep funding this effort. And now we're in the prototyping phase, so we're doing those things of defining agents, playing around with different ways of calculating statuses and influence scores, and trying to play around with different ways of relating these agents. Yeah. In the future, we hope to continue to actually get developers over and help us play around with these things. We're onboarding some mathematicians who are, trying different ways of calculating these kinds of quasi-abstract ways of thinking about entities within the ecosystem, and getting some insight out of all these really different kinds of data updates that you can have to an agent and getting something meaningful out of them.
And I think in the future, the goal is that we set up a system to structure our data in a means that it could be used just by others as well, or not just by us, but others as well. So currently we're the ones playing around with the data in our Splunk instance, but the hope is to get other individuals involved and trying to spin up their own methodologies for identifying influential entities in the network.
Yeah, and when we're done playing around within CryptoFinance, if we're successful and we start getting some meaningful results, the idea is to branch it out and start testing it out in some other fields. Someone else that we were talking with wants to use this for trying to understand participants within the energy production environment. So yeah, I think that's all we have. And do you guys have any questions? Yeah?
So if I understand what you said, right, so you have a whole bunch of sources, right? You're working as part of your development activities right now to identify, quantify, and classify those agents.
Yeah.
You're trying to do it in a flexible way so that as the networks change over time, that can kind of like self-update, so that you've got that kind of vision that you're using once you're happy with that layer, not in a static sense, but in a evolutionary sense, right? Once you're happy with that layer, then you're using that to drive insights about how the networks are performing in different contexts, be that financial or social or whatever else. Is that correct?
Yeah, that's a really good summary. Yeah.
So what are the tools that, what I didn't get is what are the tools that you're using? Because you said, straight ML, that didn't really work for you very well, right? What are the tools you're using to identify and classify those agents? How are you working that? How are you building out that layer? Because that whole concept is really critical to what you're doing. And if it's all NDA, then that's fine. I just wanted to.
Yeah.
Right? So you're not making magic wands. You're doing something there, right?
Yeah.
I assume there's some kind of ML type stuff happening at that definition.
So
you just abstracted it from your end goal.
totally. So that's kind of the part that we don't talk as much about in this talk. We're more talking about the idea, but the idea is that we will have an array of different tools, kind of like a kit, and then they can be called upon when a given data transformation, I don't know if this cut out, a given data transformation would be appropriate in that scenario. So the idea is that we will have different types of tools, and Zach can speak towards some of those.
Okay, so
Yeah.
you basically have a set of agent generators, if you want to call them that, or agent identifiers, right? So you're going to have a flexible tool set of agent identifiers that you then apply over your data streams to get your space of action, or
Right.
rather, from which you then hypothesize.
Right, so the models, yeah.
You then interpret the activity that's happening.
So the models that we're applying for, like, identifying an agent might be very different than the models that we're using to try and determine whether or not a relationship is changing. So from our data stream, there might be new agents that are arriving, but based on just being mentioned many times by current existing agents within the ecosystem. And then the idea is to have that model at some given threshold identify that now this should be a new agent that can be created within the system, and they can be integrated and determine what, another model might help determine what those relationships are. So that's a great question.
If I could just jump in with one point. Sometimes when we classify an agent, it's pretty concrete when we know that we're dealing with the same person. There might be mistakes in saying these two people have the same name. That's something that we need to parse out in that regard. But another kind of direction that we've been trying to work on and are still prototyping is related to the example looking at OTC providers. So looking at the behavior of particular addresses and their activity, and can we identify something out of the pattern of their behavior that might classify them as a particular type of agent. So those are more difficult to implement, and they kind of, right.
Thank you.
Thank
well,
you.
And some of this work that we're doing is not just internally within our company. We're speaking with researchers at universities and some people who are working on their own systems. So we don't like to tell exactly what the techniques are that we're working on, but yeah.
Oh, that's great.
Yeah. Oh, sorry. Yeah.
Can you speak up, or can you guys repeat the question?
Do you mind speaking up?
You were talking about the work that you have the interns doing when you're finding what's influencing the others. Can you speak a little more about that? Is that just a correlation, or is it more
Yeah, so some of the aspects are related to correlation of activity across different agents, but we're also trying to leverage some of the metadata that's just provided by sources to give an indication of the weightings that we were talking about between two agents. So in the example that we were going along with, which is Twitter, we can use things like user mentions and retweets and likes. Those are concrete examples of weightings in a particular direction of one agent to another. But we're also trying to work out some more nuanced techniques like correlating different activity levels and leading and lagging indicators of where signals are coming from initially in terms of ideas and influence. So that's what we have working on in the background.
Yeah, and sometimes it's as simple as seeing this person's writing an article and that article is spreading as people are tweeting about it and talking about it, right? Or every time this person retweets an article, it starts to blow up, right? So that could be kind of a simple example of influence. Yeah, Nate?
Can you expand upon like what type of clients you have today and where you think it's going to go as the industry evolves? What I mean specifically is it seems like the same sources of data are used for different use cases.
Yeah.
SEC may want to use it for certain use cases. You might have investors and institutions that want to use it for other purposes. Can you just like expand on
Yeah. Yeah, so specifically, a lot of our clients, especially in the regulatory sector, we can't talk about, but currently our market strategy was kind of to cast a broad net and try and collect one client from as many different categories as possible. And that's because you're right, there's so many different ways that you can use this kind of similar data set. And what we see in the future is right now a lot of interest from regulators, a bit of interest coming from exchanges themselves who are trying to comply with all of these new regulatory frameworks that are kind of coming out and being refined real time. So that's one big category that we're focused on right now. And then the second one after that is more quantitatively leaning prop shops and trading groups that are trying to get an edge on all of their other competitors that are just purely using the same coin market cap type sources. Does that answer the question? Yeah. Cool. Anybody else? Yeah.
So what are the ways that you guys kind of determine what constitutes a bad actor, whether it be on one of the exchanges, whether it be in social media, whatnot?
Yeah.
How do you guys?
Do you quantify that?
Well, so what we like to do is tell our clients that we're not going to provide you the truth. We're going to try and provide you all of the tools and all of the data to make your own decision. So we actually don't feel very comfortable, but we will generate an index or a score if a client requests it. But generally, what we prefer to do is to tell them what their methodology would be for defining a bad actor, and then we implement it, if that makes sense. So if you define what the activity would look like, then we can quantify that and return you a list of, all right, over the last 24 hours, these 3,000 accounts meet that criteria, and then it's on to our clients to actually do some due diligence or reference their own proprietary data sets to make decisions based off of that.
Some of the more direct ways related to blockchain addresses are, we have a couple services that provide us with addresses that might be related to darknet activity or scams that have been reported. So those are the more concrete examples, but Nick is right in saying that we don't want to tell people directly these are the bad actors. We want to give them the data and the means to discover that on their own if they have a sound methodology. And particularly with blockchain data, that's a pretty competitive field, is like blockchain forensics with Chainalysis and all of those guys that are doing that. And honestly, we probably can't compete in that regard, so our focus is a little bit different, and we're just trying to provide as many other types of data that you can overlay to come up with your own methodology, rather than just coming up with a proprietary little index that says, a D to an A. Yeah.
Have you experimented with determining valid sources of good information? So, for example, if three newspapers say gas prices are going to go up and three say it's going to go down, if there's an event where gas prices change significantly, you kind of go back and look at what you had in the story and kind of figure out what that was good or bad.
Yeah, totally. So one example of that is just tracking people on the blockchain and who have large sums of money, and seeing which ones seem to be accumulating more money, which ones are doing really well versus which ones aren't. So that's one example. Yeah.
Yeah, and a great use of Splunk that we're testing out right now in relation to the last use case that we brought up is identifying large transactions and large movements of funds in an entity, and then tracking how it affects the market 1 minute, 1 hour, 1 day later, to try and parse out whether or not there are signals there that we can be identified as potentially volatile signals towards the market.
Yeah, and kind of touching on like which sources are good or bad, another thing that we like to do is add a ton of redundancy. One of our co-founders is doing security for the Bank of France. So for just the Bitcoin price at a given time, we will have many different values. And even with blockchain data, we run our own nodes, but we also reference public services that have wallet explorers, for example, so that if you search for a single block, there's going to be multiple sources that come down, and you can actually pick which source you want to go through. And sometimes that's actually really useful if you're looking at orphan blocks, for example. If there's an orphan block that doesn't get picked up by our node, but you're looking for a specific transaction that wasn't included, it might be picked up by a different source. Anybody else? No? Okay, well, thank you guys so much. Yeah. Yeah, so you guys can, I'll hand out business cards, of course, but you guys can reach out to us on LinkedIn. We're a really small team, so if you just search Inca Digital Securities and reach out to anybody, we should get back to you pretty soon, yeah.
Thank you.
Cool, thank you so much, guys. Oh, yeah? For a development of a project? Yeah, so I mean, if it is publicly available, we'll integrate it as a source, but if it's not, we can't provide it, but our clients can integrate their own data streams. We will provide endpoints for our clients to hook up to our CDC, and we'll parse it and filter the data and enrich it in any way. And we do that with like chat channels, for example. So if you're part of a private chat channel, you're not going to want our other clients to know what's going on, but you might want to make some decisions based off of that. So you can integrate your own data stream, and we'll hook it up in whatever way you're consuming the data. Yeah.
I guess the last question is, y'all from neuroscience, some of those models, around neural nets,
Sorry, are we using a lot of neural nets, did you say? Yeah, a bit, yeah. We like to play around with different models. We've explored some of the like fringe types of models that aren't really used very often and stuff too. We go down some rabbit holes, yeah.
One of the structured diagrams we brought up, it was 3 blue rectangles, is kind of similar to how a neural network or a deep neural network is structured, and pulled from how the visual cortex is theorized to work. So it definitely plays into a lot of the ideas that we spin up for this model.
And another thing would be hierarchical temporal memory, if you know about it. It's also very influenced by neuroscience, and they also do some neuroscience research themselves on cortical mapping and stuff. So.